In this video, we'll take a look and see how to find the derivative of products and quotients of functions. So the first derivative rule that we'll look at is the product rule. So here's an example. Find the derivative. P of x is equal to x squared plus 2x plus 2 times 3 minus 2x. Notice these are two polynomials multiplied together. In the previous section, if we had a single polynomial, then what we could do is we could take the derivative of each individual term using the power rule. In this case, we can't do that because we have two functions multiplied together and it's not a polynomial. So one thing that we can do, we could multiply this out and create a polynomial. So if we take x squared times 3 minus 2x plus 2x times 3 minus 2x plus 2 times 3 minus 2x, then what we'll end up with, adding like terms, we'll end up with a polynomial that we can then take the derivative of. So this is one way to approach the problem. If we do that, we end up with 3x squared minus 2x cubed plus 6x minus 4x squared plus 6 minus 4x. Add your like terms. Our polynomial becomes negative 2x cubed. Then we have positive 3x minus 4 is negative x squared. 6x minus 4x is 2x. And then a constant of plus 6. So now the algebra work up front, now it's written as a polynomial, and we can use the product rule. So our derivative of negative 2x cubed would be multiply 3 times negative 2. We get negative 6, subtract 1 from the power, x squared, minus 2x plus 2, and the derivative of 6 is 0. So one way to do these is to multiply up front. But we won't always be able to multiply the two items, the two functions out to create a polynomial, and sometimes it's just too much work. So the product rule, there are many ways to express the product rule. If we take y is equal to f of x times g of x, if the function is given in this form, two items multiplied together, then the derivative is f of x times the derivative of g of x plus g of x times the derivative of f of x. All of these other ways are ways to express that exact same rule. I'm going to go with the fourth one just because it looks like it's got a lot fewer variables to confuse. So whenever you have a function y equal to the product of two functions, for example, our p of x is x squared plus 2x plus 2. So our function f would be x squared plus 2x plus 2. Our function g, or our factor g, would be 3 minus 2x. So I've got it written in f times g format. Then we're going to use this formula. So we need the derivatives of each individual factor. So f prime is going to equal 2x plus 2. G prime is equal to negative 2. And then using the function, the derivative, y prime, and in our case, let me use the variables that we have, p prime of x. So the derivative, p prime of x, would equal f times g prime. So f was x squared plus 2x plus 2 times g prime, which is negative 2, plus g, which is 3 minus 2x, times f prime, which is 2x plus 2. So now we've got the derivative, but we've got to go ahead and do some algebra simplification. Multiply through by negative 2, I get negative 2x squared minus 4x minus 4. Multiply these two together, I get plus 3 times 2x is 6x, outer, plus 6 inner, minus 4x squared last, minus 4x. Add together our like terms. we end up with, let's see, -2, -4 is -6x squared. -4x plus 6 is +2x, minus 4 is -2x. And then adding constants, we have -4 plus 6 is +2. So we end up with exactly the same answer, but we use the product rule instead of multiplying the two expressions together to get a big polynomial. So let's just double check and make sure we get exactly the same answer. So we want to practice and know when it's appropriate to use the product rule. So if you take a look at the two expressions below, we have y is equal to 2x times x squared plus 3x. This is in the form two functions multiplied together, two expressions f times g, because we have 2 times x. The other expression, we have 2 times x squared plus 3x. If the number multiplied in the front is a constant, you don't have to use the product rule. You can take 2 times the derivative of the inside. Okay? So that's the difference between the two. So if we use the product rule on the first one, f is equal to 2x, g is equal to x squared plus 3x, then I find the derivative. F prime is 2. Derivative of g is 2x plus 3. And then now I can find the derivative of the function by using the formula above. We take f, 2x, times the derivative of g, 2x plus 3, plus g, x squared plus 3x, times the derivative of f, which is 2. Multiply out. 2 times 2, we get 4x squared, plus 6x, plus 2x squared, plus 6x. Add like terms. Our derivative becomes 4 plus 2 is 6x squared. 6 plus 6 is 12x. So could you have also multiplied together? Yes. Okay, so in this case, it probably would have been easier to multiply 2x through. 2x times x squared is 2x cubed. 2x times 3x is plus 6x squared. And you notice if you take the derivative, you'll get exactly the same thing. Okay? For the second problem, you would multiply the 2 through and then take the use the power rule. So the in-class practice, differentiate the functions without multiplying out first, use the product rule, and then check if you want to by going ahead and multiplying them out if you want to. So let's take a look. The first few look pretty straightforward. A hint on the third one. Rewrite your function 1 over x plus 1 would be x to the -1 plus 1 times x minus 1.